All right, let's go ahead and solve this quadratic 1/2 x squared minus 3x plus 9/2 equals 0 using the quadratic formula. So if we're obviously going to use the quadratic formula, there's two things I want you to know. All right, the first thing is obviously knowing the quadratic formula. So either have it memorized, have it on your notes, or just ask your teacher, pretty please, can you put this on the board? So therefore I can apply it and I don't get it wrong because I can't remember what exactly it is. But my advice to you is if you use this formula enough, you'll have it ingrained in your memory. So don't fret it. It's not something you're going to use for the rest of your life, but it is something very important for a while you are in school. The next one is going to be the standard formula of a quadratic. And notice that it's set equal to 0. So when we want to solve quadratics via factoring, completing the square, or quadratic formula, we always want to have it in this standard form. All right, so make sure you have your x squared first, your linear term, x next, and then your constant. And then the coefficients of our quadratic term is going to be our a, the coefficients of our linear term is going to be b, and the coefficient of our constant, not the coefficient of our constant is just going to be c. Now, the thing with this problem is we have fractions, and I can agree that most students do not like fractions. However, a lot of times I tell my students, when you have fractions, like just don't worry about the fractions. Get rid of the fractions, especially when we were solving like linear equations, right? We would just work on multiplying everything by whatever the least common denominator was to get rid of your fractions. It just makes the math a lot easier. Well, thankfully, for quadratic equations, we can do the exact same thing. It's important, though, if you are going to use a multiplier to get rid of your fractions, to multiply everything by your multiplier. That is going to be the only way that you're going to keep your quadratic equation consistent for the solutions. However, it is important to know that, yes, when you're multiplying by 2, you are changing that quadratic, but the solutions are not going to change. So I just want to kind of give you this visual understanding of what's exactly happening when we multiply by a multiplier. Let's pretend we have a quadratic that looks like this. And then let's pretend we multiply by 2. Well, multiplying by 2 is actually going to be what? Vertically stretching our graph. So therefore, the solutions are going to be the same, but now maybe the graph would look something like this. Okay? So if you do decide to use multipliers, all you're simply doing is changing the shape of the graph. And if you're not unsure about this, unfortunately, this is not a technological video, but I would recommend going to desmos.com and typing in these two equations to kind of see, to make sure that the solutions are still going to be the same. And you can see the transformation there on the graph. Now, when we are solving a quadratic, if with fractions or not, I think the first important thing that we need to do is to go ahead and identify our a, b, and c. Now, some of you might be like, Mr. McLogan, I don't even want to do fractions. Can we just do an easier one, please? And sure, I'll help you out with that. So in the case, I'm actually going to do this twice. I don't know why. I'll just decide to do it twice. I kind of feel like when I'm in a classroom and students, you could see like that glaze on the students' eyes, and they're like, could you maybe show us a different way? And then you're kind of like, well, I wasn't really planning on teaching it this way, but you know what? I'll just go ahead and do it for you guys. So here's a little bonus on this video. I was not planning on doing. But what about if you wanted to do it the other way? What if you wanted to get rid of the fractions? So again, you're multiplying everything by 2. Everything needs to be multiplied by 2. And if you do that, you're going to get 2 times 1/2 is just going to be a 1, so an x squared. 2 times -3 is a -6x. 2 times 9/2, again, the 2's are going to divide out. That's going to be plus 9 equals 0. So in this case, my a is equal to 1, right, because there's a coefficient there. My b is equal to a -6, and my c is equal to a 9. So now you're making me do the quadratic formula twice. I hope you watched the video the whole way through, since I have to make it much longer. But all right, so now once we've identified our a, b, and c, all we simply need to do is do the plug and chug. And I'm telling you guys, a lot of times I am a big proponent of getting rid of fractions, but I don't think you always need to rush into doing it, because sometimes just dealing with fractions is not that really much difficult. And this problem is an example of that. Okay, so really important thing. When I read the quadratic form, I said x equals opposite of b plus or minus blah, 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 right? I did not say x equals negative b. The number one mistake students will make is they say, oh, it's x equals negative b. I already have a negative b. Cool, so I'll put in a negative. No, it's not saying negative b. It's saying opposite of b. So if you have a negative b, make it positive. If you have a negative b, make it positive, right? We're using the opposite sign. I also always put parentheses around, especially when I have a negative term, just to remind me, this is a -3 squared. That means -3 times -3. -6 squared, that means a -6 times a -6, all right? And the nice thing also over here is 4 times 1/2. Remember, multiplying by 1/2, guys, is the same thing as dividing by 2, right? So 4 divided by 2 is just going to be a 2. And all good into the next one over. Two times 1/2, same thing as divided by 2, right? So that's just going to equal a 1. Okay, so we have a little bit of extra step here, but we actually get to simplify a step here too as well, because when I multiply 2 times 1/2, that's just going to be 1. I don't really need to use this 1 as the denominator more. I can just get rid of it, right? However, up here, I'm actually going to insert a 1. And the reason why I want to insert a 1 is because when I need to multiply fractions and I have if I have an integer times a fraction, I always want to recreate my integer as a fraction. That way I can multiply straight across. But in this case, actually, I don't even need to multiply straight across because I notice my 2 in my numerator and my 2 in my denominator are going to divide out. So therefore, that's just going to leave me with a 9 minus 9, which is again equal to 0. All right, and then over here, again, be careful with your order of operations. Don't do 36 minus 4, right? We always do multiplication and division before addition and subtraction. So 4 times 9 is going to be a 36. 36 minus 36 is going to equal a 0. Okay, now I have plus or minus square root of 0. Well, ladies and gentlemen, the square root of 0 is just going to be 0. So you can see I just have my final answer, x equals 3. And then over here, again, plus or minus 0. I don't really need to do that, but I still do have this 2 here. 2 divides into the 6, or 6 divided by 2 is just going to equal 3. And therefore, ladies and gentlemen, you can see that this graph is actually only going to intersect at one point, and the solution is going to be just that 0.